Hello everyone, welcome to watch this presentation. My name is Yuan Yin. Now I'm a doctor graduated from Dyson School of Design Engineering in Imperial College London under the supervision of Professor Peter Charles. So in this presentation, I would share one of my study to you, which is related to using EEG to understand semantic and episodic memory retrieval in creative processes. I will explore the study from the following 6 areas: introduction, study aim, methodology, results, summary, and contributions. Let's start with introduction. So I would start the introduction from a word called creativity. So what is creativity? Creativity is a person's ability to produce novel and valuable ideas. So in other words, we will consider creativity is a human's ability to thinking differently. So we now know what is creativity, but how we achieve it. So we achieve creativity normally from a process called creative processes. So in a creative processes, we generate new ideas by searching and associating existing memories. So it seems like memory is important in creative process, but what is memory? Memory is the mental processes where people acquire, store, retain, and retrieve information. Normally, it can be divided into 3 categories, including sensory memory, short-term memory, and long-term memory. So we get information from environment. We use our eyes, our ear, our mouth, our nose to get information. So the information we collected from these sensors, we call it sensory memory. If we pay attention to this sensory memory information, our brain can encode this information into short-term memory so that we can store this information for a few of seconds. Then, if our brain thinks the short-term memory information is meaningful, it will be encoded into long-term memory so that we can remember it for a long time or even permanent. Later, if we want to use the information from long-term memory, we can directly retrieval from the long-term memory. So it seems like long-term memory is important during the memory processes, and it's worth to dig more. There is 2 categories of long-term memory which is important. The first one is semantic memory and the other one is episodic memory. Let's start with semantic memory. So semantic memory is usually mentioned to the perceived facts or the concept that will not change based on the spiral, based on the locations, or based on your experiments. So for example, like the current capital of the United Kingdom is London. It will not change based on where you are. It will not change based on your experiments. While for the episodic memory, it's related to the events that the individuals has experienced. So in other words, the episodic memory is based on your own experiments. So for example, like I met my friends yesterday. This is only the experiments of yours. So it has been found that long-term memory have some relations with creativity. For example, like semantic memory, it can affect creativity because it will provide some sources of new ideas. While for the episodic memory, it can also contribute to creativity. For example, like during the episodic memory process, we will reconstruct our memory and some new information will generate it, which is the source of new ideas. And also this will increase the quantity and flexibility of ideas while increasing the episodic details. However, we do not want to stop ourselves here. We want to dig more. We want to identify what is the relations between memory and creativity from the neuroscience technology levels. So normally we can use EEG or maybe we can use fMRI to identify the relations between memory and creativity. So EEG, it is a kind of devices can detect your brain waves, while fMRI is a kind of devices to identify your blood speed and in this way to report your brain conditions. It has been found that the memory has related to a place of the brain called the MN. And the researchers also go deep, and we have found that the semantic memory will relate to the LAG, LPL, and PCC, while the episodic memory will be related to the LPG and RPL. I have also used two images to help you better understand where these areas is. So, the existing studies, we try to summarize our research aim. We will identify the different EEG activities during the memory retrieval in creative processes. The EEG is what we have mentioned in introduction. It's a kind of devices that can collect the brainwave data. The memory retrieval is the semantic memory and episodic memory processes. As for the EEG activity, we will identify the following three activities, which is the active brain areas, event-related potential, or we call it ERPs, and the power spectral density. So just in case you do not know event-related potential and power spectral density, I try to include some more explanations for these two words. As for the ERPs, it is used to measure the brain response that is direct result of a specific cognitive or event. So obviously in our study, it will be the event like the semantic memory and episodic memory. While the PSD, it is the frequency content of the signal or the distribution of signal power over frequency. Or in other words, you can understand it simply like it can reflect the relations between the bond waves and which part of the brain is active. So after clarifying our research aims, now we try to promote our methodologies. We recruited 30 participants and we asked them to use 16 channels EEG devices. So these 16 channels include the four parts of the brain, which is the frontal lobe, parietal lobe, temporal lobe, and occipital lobe. We asked the participant to finish two kinds of tasks. The first kind of task is called episodic induction task. So in these tasks, participants were asked to construct a sentence that few people would think of based on the words or the image that they were given in 20 seconds. The second kind of task that participants need to finish is the semantic induction task. So in this kind of task, participants were asked to retrieve related stored information that similarly few people would think of based on the given words or image in 20 seconds. So each participant will finish 30 trials in total, and 15 of them is episodic induction task, and another 15 is semantic induction task. Considering this is an EEG study, so we also show one examples of how each trial looks like. So at the beginning, the participant will see 2 to 5 seconds where is a cross in the center, and then the participant have 5 seconds to identify the words or the image, and then they will have 20 seconds to finish this task. After collecting the data, we need to pre-process them. So first, we ensure the reference electrodes was placed on the left and right mastoid, and the EEG signals were processed by EEG lab. It is a kind of plug belongs to the MATLAB. Then we put the EEG signals in a 50 Hz NOR filter to remove the electronic artifacts. And then signals were passed through a bandpass filter, which is from 0.1 to 100 Hz. The result was represented by the average results of all participants in each section. And for each task section, because we have two, one is semantic memory, one is episodic memory, the blank artifacts were removed with the help of ICA. After pre-processed data, now we can see the results of our research. Let's start with the active brain areas. So from the result we can find the semantic memory is related to the activity of left frontal lobe, while the episodic memory is related to the frontal lobe. So it seems like episodic memory will include more brain areas compared with the semantic memory process. But considering frontal lobe is related to the divergent thinking, our study tried to support that how semantic and episodic memory retrieval influences creative process will through affecting the divergent thinking processes. For the ERPs results, we can find that semantic memory needs around 311 milliseconds to be invoked, while the episodic memory may need much longer, which will be over 2,000 milliseconds. So based on the definition of ERPs, we can know that ERP related to the brain response to some specific cognitive event. So based on this definition, we can find the semantic memory need a shorter response time compared with the episodic memory. This result may help us to explain why episodic memory is less likely to occur in our creative processes. Because episodic memory needs a longer time to be invoked. During this long time, the semantic memory process, which needs a shorter response time, may happen. And this means the semantic memory will interrupt the episodic memory process. Now let's see the power spectral density results. So the power spectral density can be used to provide insights on how different brain regions and type of brain waves are related in some specific cognitive tasks. So here we show the two images of the semantic memory results and episodic memory results. Now let's see the results in depth. Let's start with the semantic memory result. Based on the semantic memory result, we will find that when the theta wave is active, the frontal lobe is where the theta wave is mainly located in. We have known that the theta wave is related to the focused attention, while frontal lobe related to the complex cognitive functions. So considering this is the semantic memory, so we can summarize that in the semantic memory process, the attention will be paid for reasoning, planning, and problem solving. Whereas for the alpha wave result, we will find that the alpha wave is active in the frontal and temporal lobes. The alpha wave is related to some relaxed condition or some not alert condition. So we can find that in the semantic memory process, people will relax to search the semantic information, which is important to build up or increase the creativity. As for the beta wave, we will find that the beta wave is always related to the temporal lobe areas. So based on this, we can summarize that when people have the semantic memory process, some active language processing and comprehension will happen, which is the core thing of semantic memory. Let's have a look at episodic memory results. Similar with semantic memory results, if the theta wave is active, it's always related to the frontal lobe. However, considering episodic memory is related to the personal experiments, this time we summarize that during the episodic memory process, The attention will be paid to recalling personal experiments. As for the alpha result, we will find that the episodic memory result is different with semantic memory ones. So in episodic memory process, if alpha wave is active, it's always related to the temporal and parietal lobes. The parietal lobe is specifically related to the spatial orientation and navigation. So this time we try to summarize that during the episodic memory process, the people will relax to spatial orientation and navigation. This will contribute to creativity. As for the beta wave result, it's still a little bit different with semantic memory result. In episodic memory process, when beta wave is active, the temporal and occipital lobe will be active. The occipital lobe is especially related to the visual processing, and this means during the episodic memory process, some visual processing cognition functions will work. This is the thing that semantic memory will not happen. So now let's have a quickly summary about our results. So our study identifies three kinds of activities from the EEG. The first one is active brain areas, the second one is ERPs, and the last one is power spectral density. So from the result on active brain areas, we have found that the semantic and episodic memory retrieval can influence the creative process through affecting the divergent thinking process. Well, from the ERP result, it can be used to explain why episodic memory is less likely to happen in your creative processes. Well, based on the power spectral density, we have found that the semantic memory will relate to the language and auditory processing and language comprehension. While for the episodic memory, it will mainly relate to the experiments retrieval and sensory integration, and language and visual memory processing. Now, let's see the contributions of our study. Our study can help researchers and educators better understand how people use long-term memory in their creative processes. This will raise the awareness of the importance of long-term memory for creative design processes. Also, our study can bring insight into how different brain areas and types of brain waves are connected during the semantic and episodic memory process. So this will be used as a pre-step to trigger the thinking on how to use EEG to understand the creative design processes. Also, this will be helpful for researchers and educators to understand how to enhance memory ability to increase the creativity of the outcomes. For example, like from increasing the visual processing ability. So here we included some references that we used in this presentation. This is the end of our presentation. Thank you for your listening. If you have any questions or have anything you want to discuss, please feel free to use the following email in these slides to have the communication and discussion. Thank you for your listening.